result, come back to the initiator, which can be you. Generally, this is the schema of such a transaction. We have the root, and then we can start to open sub-transactions and have service composition, at least 3 different compositions: sequential, parallel, alternative. We can even delegate the whole transaction to a coordinator. We have data orientation, and we have all of our dependencies. Now, more text-based. This is a little bit more complicated transaction tree. As you can see, these can be converted to a transaction context, and then you can have the sequence diagram, UML sequence diagram of this scenario. Then we have to go for pattern behavior. Before I start talking about the behavior of a distributed transactional implementation, I want to know if you have any question. What is your name? Sorry?
Ali.
Ali, I don't know if when I start, you've got some sort of answer to your question that you've asked me about, is it okay to use PHP? You can use any sort of languages because you are in, you want to implement your services in realization level. Now, let's see the pattern behavior of a distributed transactional system. This is a simple history of a transactional runtime. First, I will explain this vector language. As you can see, each part is supposedly a coordinator. We have a distributed coordinator. We have 3 participants with 3 coordinators. And in the beginning, there is no services. First step, a sequential service composition. The first service will be executed. In the second step, we have 2 different scenarios. This is alternative service composition. Service B1 can be executed in the second coordinator, or service A2 can be executed in the first coordinator. If we go for right side of these alternative scenarios, we have a parallel. This shows the parallel service composition. We have the parallel service composition when service B1 can be executed concurrently with service C1 in the third coordinator. And this will be the result. Now, let's look at the history. We have the history of this concurrent execution. It doesn't matter which one will be run first, and we don't have this control. That means you can see history 1 and history 2. These 2 histories are equivalent. This is what I set, and this is the actual script of these histories. But probably you ask, what will happen if there is a failure? One of these services cannot be run, or one of these coordinator does not respond. This is the pattern behavior for the situation that distributed transactional system has a failure. It looks a bit complicated, but it's not that complicated. I'll try to explain it by word, and then you can match it with diagram. Imagine, first, we have empty vector. Second step, the first service in the first coordinator will be run successfully. Then we go for right side. For some reason, it cannot be run. We have a failure here. In the conventional view, the whole transaction has to be recovered, undo. In our model, in the distributed model, we can go for alternative scenario. Now, we have to have cancellation or compensation. You can see here, we call it forward recovery. And then, after finishing the compensation, we can go for branch, left branch, and execute service B1 there, and in the second coordinator, and service A3 in the first coordinator. This looks like a very simple thing, but it's not simple by no means. It is pretty complicated. If simple failure is complicated, solving the dependencies can be really complicated. For solving dependency inside of a transaction, when the service is accessing some shared data, we have internal dependencies graph, and you can see the schema. This is XML schema actually by Visual Studio that shows the dependency graph, and you can trace it for recovery procedure. And if you have released the data for another transaction, we have external dependency graphs. I'm not going to go through the complexity of the system and explain the complication of locking mechanism or using particular semaphores. There is implementation, and there is source code, open source projects that at the end of the lecture I will give you link. But you can imagine, can be even a simple scenario can be quite complicated. You can have several participants in a simple scenarios of shopping or business-to-business transactions. Now, let's talk about a little bit about these business network properties. Because now we are talking about distributed system in service-oriented computing. The first things that we may have is fragmentation in the network. We cannot access some specific coordinator. Then we had recoverability. For avoiding to pay the whole cost for recoverability, that means coming back to the first step, we have forward recovery. Forward recovery rely on alternative scenarios or alternative path inside of a transaction. Then why we have the distributed coordinator? Because we want to provide local autonomy, or that loosely coupling that we talked about it in the second or third slide. And because lots of participants can be small and medium enterprises, their business activities can change. when we have local autonomy and loose decoupling. I mean, loose decoupling give them facility for changing their actual implementation without forcing the change on the higher level of service-oriented computing or service composition implementations. And we hope to introduce facilities for giving a stability to the whole system. Very quickly, in a very small transactions, you can have several participants. Normally, one of the participants initiate a transaction, then we have that internal and external log mechanism for dependency graphs. We have different pattern behavior, and what I'm not going to talk about, we have a concurrency control for locking mechanism for being sure that this ordering and accessing to data is based on the scenario. And then the recovery can be done easily. Okay. This was for WS type of services. Therefore, these WS type of services could use the classical transactional model like BTP or WS transactional model, or as we talked about, using distributed coordination with a little bit more complicated system, but having the whole local autonomy and supporting all sorts of pattern behavior. But the next step that you may have heard about is RESTful implementation. Because REST, concept of REST and restfulness is pretty new, you may not find that many ready-to-use transactional model. You may have to do some of stuff by yourself. As you can see, the repositories, even repositories, are not like a single centralized repository. They can be decentralized. You may have to deal with all sorts of complication for accessing them, and you may have lots of redundancy. These are the things that you have to think about when you go for RESTful transactions. I'm not going to talk about RESTful transactions that much. We have in University of Surrey a little bit research on RESTful transactions and a little bit publication, and still we are working on it. So far, until here, we had the nested composition in terms of transactions. We provide loosely coupling. It supports a dynamic environment. We have all sorts of delegation in our transaction context. We solve the data dependencies by introducing two different types of dependency graphs. And we have talked about platform failures and what we are going to do when we have a failure. Then what we haven't touched that much is the situation with completely stateless environment and restfulness.